What's the point of Kw? What can we learn from the ionic product of water? Let's find out in some chemistry with Nav. So water constantly dissociates into H plus and OH minus ions in an equilibrium, which means that we can write a version of the equilibrium constant, which is called Kw, the ionic product of water, as being H plus OH minus, and at 298 Kelvin, which is room temperature, that has a value of 1 times 10 to the minus 14. But let's just rearrange that slightly, because we know that H plus must equal OH minus, and this is because it's in an equimolar dissociation, which simply means that when water molecules dissociate, they must produce both one H plus ion and one OH minus ion, so they're equal moles being produced. And if I have that, then that means I can replace the OH minus and call that expression H plus squared is equal to 1 times 10 to the minus 14, which means that H plus is equal to the square root of 1 times 10 to the minus 14, which happens to equal 1 times 10 to the minus 7, and that means that pH is the negative log of that, which is just 7. So that means that pure water at 298 K has a pH of 7, which is what we expect and what we know. If we look at something just slightly different though, because at 373 Kelvin, so that's 100 degrees centigrade, Kw is equal to 51.3 times 10 to the minus 14. And yes, if you're a pure mathematician, that should be 5.13 times 10 to the minus 13. But what I'm trying to show you is that the value of Kw has increased. So as you increase the temperature, you are increasing the concentration of H plus and OH minus ions, which means that the dissociation of water must be endothermic. The forward reaction is favoured as temperature increases. But now look what happens when we plug that into the previous expression. H plus is equal to the square root of 51.3 times 10 to the minus 14, which means that pH is equal to the negative log of that, which happens to come to 6.14. Now, we know that water dissociates into H plus ions and OH minus ions. It has to be an equimolar dissociation. That does not make water acidic at 100 degrees C. What it means is that the pH scale has to adjust for temperature. So at 100 degrees C or 373 K, the neutral point of water is actually pH 6.14. And this is what we can get from the Kw expression.